Here's another example of the zero factor property. If we have a quadratic equation that looks a little different, 3x squared minus 7x equals 20. Now this looks a little bit different. Remember that a quadratic equation has to equal 0, so I can go 3x squared minus 7x, and I'll just move the 20 over by subtracting 20 from both sides. Minus 20 equals 0. So now I can factor this side, and factoring this is going to be a little bit harder. The way I like to factor this is I know that there's going to be this 3 somewhere, so we're going to have a 3x and an x. I know that. The values here are going to multiply to 20, and I only have certain choices. I can have 1 and 20, or I can have 2 and 10, or I can have 5 and 4. Now in order to end up with negative 7x here, I have to take one of these numbers, and then the other part of the pair has to be multiplied by 3. And then those two numbers have to combine to get to minus 7. So that's 20. Okay, so 3 times 5 is 15. No, 3 times 4 is 12. Okay, there's my set right there, 12 and 5, and the difference is 7. So 3 times 4, so 3 times the 4 is 12, and 5 is here, so I'm going to be ending up at minus 7, so I have to have minus 12 and plus 5. So 3x, if I just FOIL this backwards, I can double check it. 3x squared, correct, plus 5x minus 12x ends up with minus 7x, and minus 4 times 5 is minus 20, so that's correct. So we have our blue solution and our pink solution almost ready to go. This one here, 3x plus 5 equals 0, solve for x. This one over here, x minus 4 equals 0, solve for x. Well, this one's easy. X minus 4 equals 0, so x equals 4. There's my blue solution. That is one of the roots. This one's a little bit harder, so I'll go 3x. I subtract 5 from both sides, equals negative 5. Divide both sides by 3. I get x equals negative 5 over 3. And that's my pink solution. And if I were to graph this one, I know that the graph would look something like this. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. X equals 4. That's the blue solution. Minus 5 over 3 is somewhere like that. And the parabola would look something like that. Well, that's a drunk parabola. You get the idea.